Over the last few years, object relational mappers, or ORMs, have become very popular in the development community. And it's easy to see why. ORMs allow us to work at higher levels of abstraction. They also eliminate the need to write a lot of very repetitive data access code just to get data into and out of the database. Consequently, they help us increase our productivity as developers. On the downside, though, removing us from having to work directly with the database gives us less visibility and less control into how our data access code is executed. And so one of the side effects of this is that if you just leave your data access up to the ORM and don't think about how the data access is performed, you can get some very poor performance. Let's see what we mean by this. I have a very simple application here that's using Entity Framework to connect to Oracle. And what I want to focus your attention on are these lines here, where I have a link query to find all the applicants that have a GPA over 3.5 and an SAT math score over 700. This is one of the things that we like about ORMs, is the fact that they make it very easy to write this fluent type code, and the ORM will worry about the details of generating the SQL for us. The issue is that it becomes easy just to think about interacting with the ORM and forget that behind the scenes, this link code actually has to be translated into SQL and then run against Oracle. And in this case, there's not an index on either of these columns, so this query will end up performing a full table scan. This situation can occur anytime that we have these methods that return an IEnumerable object and let us build these fluent type queries against the IEnumerable object. Whether we're using Entity Framework Database first, like I am here, Entity Framework DB context, a repository pattern that returns an IEnumerable, and this can also occur in other ORMs. By having this fluent interface where we can easily add criteria against our IEnumerable object, we have a very flexible interface. We can easily construct any combination of criteria that we want. The downside of that flexibility, though, is that as we get further abstracted away from our SQL and the tables that the SQL will run against, it becomes easier to lose sight of the fact that we aren't querying a small number of objects in memory, but this query will have to run against potentially a very large database table. And if there are not indexes on our columns or our criteria is not selective enough, we could experience some very poor performance. So the practice you should follow is, understand what your ORM is doing in terms of the SQL it is generating and running. And make sure that you evaluate this SQL just like any other SQL that you would write yourself, by examining the execution plan and appropriately indexing columns in your tables. If need be, don't be afraid to take back control from the ORM in certain situations that require high performance. While these tools advance every year, there are still some scenarios where handwritten SQL will provide much better performance.